So it is not only those problems that have got an exact solution that you can use the GDC with. In fact, you need problems that have got less exact solutions for the GDC. And a problem like this, which is one of the things that I've asked you to do, would require you to use a GDC. There's no way anybody would be asking you to solve this kind of problem without a GDC. The key points here to note is that x lies between 0 and 15, and those values will mean that the units are almost definitely radians, because there won't be that many angles less than 15 if you're measuring in degrees. And the other thing is to note that the answer is required in 1 decimal place. So what I would like to do here is first establish what graph are you going to plot, and that will be the graph of sine x minus 0.3. That or the graph of y is equals to 0.3 minus sine x would give the same result. The only difference is that while in the first case we have brought the 3 to the sine x, in the second case we will have brought the sine x to the 0.3. The only difference is that one of these graphs will be a reflection of the other, but the points where these graphs intersect the x-axis are going to be the same. So again, we will need to go to the GDC and go to the graph of y equals, I can leave my other graph there and draw the graph of y is equals to sine x. I'll need to close that bracket, and then minus 0.3. And the other thing I need to take care of is the domain. The domain this time is from 0 not to 2 pi but 0 to 15. So I would need to draw that graph, and since this other graph is still showing, I don't want it. I would deselect that graph so that I only draw the graph of y is equals to sine x minus 0.3. So therefore the resulting graph looks like that, which I transfer to my paper, my OneNote, whatever it is, and I would have a graph looking like that. Is that the end of it? No, it needs to come back there. And then from that I would now go ahead and find the zeros. So the first zero is, I want to find the first zero which is closest to the x-axis there, the y-axis, sorry. So that would be that point there. So left bound would be that, right bound would be a point after it, and the result is x is equals to 0.305. so that's the first result. So sine x is equals to 0.3 has solutions. X is equals to 0.305. The second solution, same process, second function of trace. I want a 0, I want left bound here, I want right bound here, and solution is 2.84. These are radians, by the way. You need to include units. And then again, second function of trace, I want 0, number 2. Could actually type in just number 2, and then left bound there, right bound there, and solution is 6.59, and you can continue and produce all of these results. There will be 1, 2, 3, 4, 5 of them. So there will be 5 solutions. That's the key thing to this, and they will all lie between this value 0